I don't know how many of you play it, but it's an interesting challenge, right? Which is which word to guess next, right? The problem space is, it's obviously not a query problem, right? It's a, I don't know, maybe it's a mathematical optimization problem, but you've just made the first guess in Wordle, right? And you want to know which one to do next. Well, how do you solve this problem? Here's how I would go about doing it, is you'd look at the possible guesses, right? And there's about 13,000 words. You'd look at the possible guesses and you'd say, okay, for each guess, let's say, suppose I guess wharf, right? What are all the possible answers that I can get, right? There's 3 colors times 5 squares, so there's, 5 cubed possible responses, up to 125 possible responses, right? And then a bunch of words in Wordle's dictionary are going to be in that group, in that particular group. So for example, if I guess wharf, then if it comes back black, black, yellow, green, black, then there's actually a total of 60 words it could be, right? And if it comes back black, black, green, green, black, then there's a total of 22 words that it could be, right? So what I want to do is choose the word that has the maximal information content, which actually means choosing the word that produces the most groups. So Morel, ironically, considering I'm talking about Morel, Morel is actually a really good guess because it returns 47 groups, and so the average size of those groups is going to be smaller, right? Which means the next word is on average going to have a smaller set of words. It's going to narrow down the response. So the problem is to look at all the possible words I could guess, which is 13,000 or so, right? And then look at all the possible answers to that, which is again 13,000 or so, and figure out which is the best. So it's an optimization problem. I'd say it's a medium data problem, right? It fits within memory, but it's not a small problem. And you definitely wouldn't want to solve this in SQL because, I mean, where do you even start? So I was putting this together on Thursday, and like playing it on my phone as I was doing it because I wanted to take some screenshots. So Morel turned out to be, one of the most promising words. So I said, well, okay, that looks good. So I put Morel in. So this is the basic algorithm. You'll see the code in a minute. I put Morel in, and what happened? This is running this program in the Morel language, and it basically says, mask count is the number of distinct groups that you're getting, and you can see like on Morel is on line 4 or something, 49, right? That's a pretty good word. So I decided, well, let's just put Morel in, and it turned out to be the answer. So this is a very poor example. But anyway, the program works, and this is the program. So the program is, it's about 2 pages of code. And the first page this is pretty typical in programs that you write to solve real world problems. This is actually nothing to do with crunching through the data. This is just futzing around with like converting black, yellow, green into a bit mask, a number between 0 and 125 that represents this, right? And just pulling strings apart. So these are just these dumb little functions you have to write that if you were trying to solve this problem in SQL, you don't really have much of a chance to do these kind of calculations in SQL, right? You'd have to write 17 pages of code to get this to work. And then this is the part of the code that actually does the work. So the first line there, words, I'm actually reading it from a local file. So that first line is a query from w in file.wordle.words. That is a little Morel query. You can see it looks a little bit like a SQL select statement. And then these mask count, best guesses, and remaining, these are functions that each of them has a little query in them. From W and remaining words, group by M, compute count, right? So it's doing a form of select distinct. Anyway, that is the whole program that solves Wordle. And what is interesting is I started off as thinking this is a general purpose problem, and then after a couple of iterations, I found I'd actually written some queries. In other words, I was writing relational algebra in a problem that I didn't initially think of as a database problem at all. So I think there's a lot of problems like this that are relational algebra plus a little bit of general purpose compute capabilities. They're just out of reach of SQL, and yet they're perfect things to be running on these massively powerful database engines that we have today. We just can't exploit these database engines because the only language we're allowed to talk to the database engine is SQL, which is not Turing complete. So, this is a language to more fully exploit these database engines that we've already built. So, yeah, I wanted to explore what is the difference between a query language and a programming language. Is there any difference at all, right? Maybe there's a difference in emphasis. I want to talk about a few things that are wrong with SQL. I mean, I could talk for a very long time about what's wrong with SQL. There's obviously a lot right with SQL, right? It's survived for a very long time. I wanted to examine some other query languages in other spaces and just see what, is there anything we can learn from those other languages, and then, introduce Morel. And my real agenda here is, so this is not a company. I left Google like a month ago. I've been working on this in weekends for, a little while, but this is not a company. It's not even really an open source project. I mean, it's just been me working on it. So my real agenda is I want some of you folks to try this out. Tell me whether you like it. Use it in your companies, contribute to it, and maybe in 6 months or a year's time, we'll have a whole bunch of people using it, and maybe there's a company that comes out of this. But really, this is a very early stage, just finding out, do people even like this? And are there any obvious ways that it could be improved? Like, do you really hate the syntax and you wish there were like braces, rather than, yeah, and anything's on the table at this point. So, first of all, I'll be talking a lot about algebra, relational algebra. I'll be talking about query languages. I want to just define the word algebra because, some of us have nightmares about algebra from school, but the teacher never actually told us what algebra was. So, mathematically speaking, algebra is a collection of values, operators, and laws. So, here's a couple of algebras for you, right? On the left is the algebra we learned at school. So, A plus B plus C. A and B and C are all real numbers, right? Or A times B plus A times C, right? On relations, these are kind of analogous, right? So if P, Q, and R are relations, we can form the union of those relations. And then below it, we're joining P and Q, and then we're natural joining P and R, and we're uniting results together. And the laws are, we all know these, we all learned these in school, right? That we can change the order of addition, right? Or we can use De Morgan's theorem to change the order of multiplication. And it just so happens, because I chose this example, there are exactly analogous laws for relational algebra. Not everything in relational algebra is exactly analogous to arithmetic, but there are a lot of these laws, and my main day job is writing query optimizers, and query optimizers are powered by these laws, these ways of rearranging the equations so the semantics are preserved, and hopefully it's more efficient to execute. So I'm very interested in algebras. Okay, so the other side of the equation, functional programming. So here's an example of a functional program. This is written in Morel, but it would work exactly the same in a language like standard ML, which is the ancestor of Morel, or in OCaml. So yeah, 1 plus 2, it just says, okay, the answer is 3. Concatenate 2 strings. I can define a list of integers, and I can define a function. So filter is an interesting function because it takes a list and a predicate and applies that predicate to every member of the list. And if the predicate evaluates to true, it includes that in the result, and if it evaluates to false, it eliminates it. So if I apply the filter function with a predicate that says is the number even, then 1 through 8 turns into the list 2, 4, 6, 8. So filter is a function. It also happens to do exactly the same thing as a SQL where clause, right? So the filter function does exactly the same thing as the relational select operator. So here's the kind of correspondence, right? Here are the basic operations in relational algebra, and we can implement relational algebra in a functional programming language by defining these 6 functions, right? So there's an awful lot of correspondence between the two. In Morel, I'm just trying to bring the two things closer together. So, is SQL a functional programming language? What do you all think? Yes or no? Who thinks it is a functional programming language? Only two, okay. What's that?
The definition. Can I query it like a select statement?
Yeah. So, a functional programming language has user-defined operators and types, functions as values, right? Local optimizations, it's Turing complete, and it tends to execute locally, right? It tends to execute on your laptop. And a query language, yeah, it has only the built-in operators like the 6, relational algebra operators. It only has one bulk data type, which is a multiset, otherwise known as a relation. And the optimizer is very smart. It can do algebraic rewrite. So those are the differences, but what is in common between, there's an awful lot in common. So it treats data as immutable, right? It does good type checking, type inference and type checking, and it does very aggressive inlining. So when you define a view in SQL, it doesn't evaluate the view and then substitute that into your query, right? It basically algebraically inlines it into your query. So those are the things they have in common. So what about if we create an algebraic language where we kind of take the best of both? So you can take the built-in relational operators, but you can add your own operators as well. You can add algebraic rewrite rules so that, let's suppose you define a matrix type and you define, matrix multiplication, matrix inverse operator. What would this language look like? It'd be kind of a query language, but a query language for matrices and not for relations, right? It'd be Turing complete because, hey, some programs you want to be able to write, complex recursion and whatever. And choose your own engine, right? You could run it locally, but you might also actually want to run it on, on a Spark cluster or something like that. So in the kind of universe of different query languages, right, SQL is really just specialized in transaction processing, CRUD, retrieval, reporting. It does a little bit of analytics, but as we know, it has problems with things like measures, right? Certainly doesn't do general purpose programming and other kinds of stuff like linear algebra and graph processing SQL's not too good at. So the idea of Morel is to expand, is to kind of build out from the base of what SQL can do and create a language that can address some more areas. So a few people have asked me this already, what do they say? If you come at the king, you better not miss. SQL very rarely loses, right? So I'm not optimistic that I'm going to destroy SQL and I have a feeling SQL is going to be around in 50 years. But I have a feeling it's going to fade away, or there's a various kind of, number of possibilities. So SQL will continue to grow. It's just kind of like like the mystery house that's been extended so many times. It's definitely sprawling, right? There's different bits of it that don't make sense. People will carry on using it, but it's becoming rather a messy language. I also noticed the ISO standard is declining in importance, and kind of the changes in SQL are being led by particular vendors. So DuckDB is a good example of throwing new things like, I don't know which vendor came up with a qualify clause. I mean, that kind of spread like a virus a couple of years ago because it was such a good idea, right? That definitely didn't come out of the ISO committee. I also noticed Postgres is doing a very good job of just maintaining sanity. If Postgres does it, it's probably the right thing. But what I predict is databases will speak more than one language. In other words, you'll be able to speak SQL to them, but there'll be other languages that are more suitable for your use case. You're still going to be able to see the same data sets. You're still going to have the same transactional context, but if you want to talk another language, such as Morel, the database will speak it. And if you've got things like a semantic layer on top of the database, then SQL just becomes machine code, right? It's a language that is supported by the database, but no one actually uses it, right? They're all using a different language. So there's a variety of options, which gives me hope that, things might change. So, and I did a quick review of various programming languages there, and I asked Claude to generate the same query in those languages. And you can see an awful lot of differences on how they're laid out on the screen. And one of the conclusions is query languages tend to match the let's say the culture of the user that's using them. So for example, MongoDB, which is intended for web developers, of course it's written in JavaScript and JSON because web developers want JSON, right? Datomic, it's embedded in Clojure, so of course there's parentheses all over the place, right? Yeah. But these languages are all doing basically the same thing. They're all doing relational algebra under the covers. So there's Morel at the top, and I'm very proud to say it's very concise. That's one of the goals of Morel, is just don't repeat yourself. Notice you don't have to declare any types in a Morel program. That's in common with SQL. A very important choice was I chose a functional programming language that had a really good type inference system, so you could just write a query and it would just figure out what the type of everything was. XQuery is much maligned, but a lot of people have pointed out that Morel has a lot of similarities with XQuery, because XQuery, if you can get over the XML syntax, XQuery handles nested data extremely well and is actually extremely powerful. Okay, let's just look at one of the recent languages that I think is very interesting and very constructive is Google SQL. So here's an ordinary SQL statement. Starts with select, right? So Google SQL pipes, which came out like about 12 months ago from Google, it puts the from clause first, which is very important, and then each successive line is basically one relational algebra operation. And you save yourself the effort of, you don't have to write the group by items twice. In fact, there's a more concise syntax. I can group by and order by simultaneously. But it's basically the same query, it's just reordered. I think it's actually genius, because Google wants to maintain backwards compatibility. And the fact that Google SQL Pipes uses literally the same SQL parser means the type system's the same, the functions and operators are exactly the same. You can just write it in a more convenient order. So this is fantastic for people who want a good backwards compatibility story. So it's a very pragmatic evolution of SQL to fix probably the biggest mistake, which is the fact that the from clause should have come first. So here's another language that's rightly got a lot of attention. Prequel is not SQL, but it's a nice, friendly, concise language that has the from clause first, has a lot of good ideas in it. And then lastly, Morel, which structurally looks very much like Prequel. Yeah, more about that later. So, here's the query syntax. By a query, there's actually three kinds of queries in Morel. The most common one begins with the word from, but you can also have a query that begins with exists and for all. So those are existential quantifications. So you can just say, is this condition true for all records in the set, or is this condition true for any record in the set? But they have the same basic structure, which is, you read from a bunch of tables and then you feed the results through a bunch of relational operators. So, this is the set of relational operators on the right-hand side. Also notice, there are a few exceptions here. So the order items have a special syntax, so I can say descending, but most of the things inside a query are just expressions. So contrast that with SQL, where the syntax of what you can put in the select clause is completely different of the syntax of what you can put in the from clause. SQL is several languages all smushed together, and it's very inconvenient. If you have a column in SQL whose value is a collection, the way you work on that collection, you use completely different operators and functions than if that was actually a table. So it's one of SQL's biggest crimes, is the fact that tables are handled very differently than collections inside columns. Morel fixes this stuff. So another of SQL's crimes, the billion-dollar mistake. Does anyone know what I'm talking about? So look at this query, okay? And I execute this query, and so this query is, this is a valid SQL query. I'm interested in find all employees in department 10 who earn more money than all the employees in all the programmers in department 20, right? And for some reason it returns no rows, right? And I can't figure out why and end up debugging it. Well, what happens is, it so happens there are no programmers in department 20, okay? So what happens? So this select max returns null, okay? And salary greater than null returns unknown, which basically eliminates all rows, right? I wish SQL had told me this. I didn't actually want this kind of clever three-valued logic. I just wanted to, if there's no employees, then if there's no programmers in department 20, obviously I want all the employees in department 10 to come back, right? So null isn't really helping me there. So why does the language even have it? So there's a bunch of reasons why you might want null. Maybe you empty strings, right? Back in the day, or if you put null into Oracle, if you put an empty string into Oracle, it was stored as the same as null. A relationship that doesn't exist. So let's suppose an employee that doesn't belong to a department, or let's suppose, I don't know, somebody doesn't have a social security number because they're not a US citizen. I mean, there's all these kind of seemingly reasonable reasons why you would want null. It's just in a functional programming language, there's better alternatives, right? You just should show empty strings as empty strings. For missing references, missing values, you can use an option type. So you can just say, either this is an integer or it's none, right? And you cannot accidentally treat the word none as a null value or a zero or whatever, okay? The unknown Boolean type, I think, is completely unnecessary. In the 1980s, they had this idea that we were all going to do fuzzy logic in our SQL programs, and who even thinks about fuzzy logic anymore? And then aggregation over the empty set. As we just saw, the max over an empty set, null is not the answer we want. In this case, we probably want the answer 0, right? If there's no programmers in department 20, we probably want to return the answer 0. So here's that SQL query again, and here it is in Morel. And I'm actually forced, well, this is one way to write it, okay? So in Morel, the max function, you actually have to say what is going to be the value if the set is empty. Because it can't return, it is not able to return null, so you have to give it a value as the sentinel value if the set happens to be empty. Or you can just use this for all syntax, which is kind of closer to what you actually wanted. Find all employees in department 10 such that the salary of this one is greater than the salary of all programmers. Of course, if there are no programmers, then that for all trivially succeeds, right? Which is what you wanted. So, types and collections. So in SQL, the collection type is, in academic SQL, academic relational algebra, it works on sets. But in SQL and industrial databases, it's a multi-set. In other words, it's an unordered collection, but the same value is allowed to occur more than once. In a functional programming language, the standard type for collections is a list. What's the difference between the two? Well, a list actually has some ordering to it, right? In some cases, the ordering is actually important to you. A collection would just mean a different thing if it's reordered, right? If you're interested in your employees ranked by salary, that the order is important in that list. So some interesting things in Morel, how we deal with collections. But this is these are the data types supported by Morel. It's a pretty common list for any programming language. You've got the primitive types. You can define abstract types. You can define your own types like instant, interval, point, and so forth, and you can treat them as if they're primitive types. There are the collection types, set, list, and bag. Because it's a functional programming language, you can have function types and type variables. So you can say a list of, the filter function earlier. You'd read this type as alpha to alpha list to beta list, which is to say, if I give a function that converts A to B, and I apply it to a list of A's, then it will return a list of B's, right? So this allows the language to have polymorphism. And then algebraic types, which is a fancy way of saying record types. So every record has several fields. And the sum type, otherwise called a tag union type, which allows you to say, it's either an employee or a contractor. So this is the kind of data you can define in Morel. It also just looks an awful lot like JSON data that you've got in JSON. You've got maps and you've got lists and you've got primitive types. So this is what real data looks like. It's not, as Lloyd would say, the real world is not rectangular, right? It's a richer data model. So in Morel, I wanted to be able to accommodate the natural way of doing functional programming over lists, but also to be able to interface with SQL tables and use a bag or a multiset type. So I've been working on this over the last few months to basically, you can write a query that, say, combines a list with a multiset, and you can convert between the two. So if you want your data to be ordered, then you can do that. If you want your data to be unordered, you can do that. And so the order keyword, which already is in SQL, it will take an unordered collection and order it. There's a new word, unordered, which is to say, even though this collection is ordered, I want you to treat it as unordered. And so how all the operations work has different semantics depending on whether you want ordered or unordered. Okay, so here's an example. The first one, we're iterating over a list of integers, a list of strings, and a list of integers, right? So I'm doing you can think of it as a join of three lists, but it returns an ordered list. In other words, it behaves like a for loop in a nested for loop in any language you would write. And it's really nice to have a deterministic order if you're working over lists. On the other hand, in the second example, my collections are, so dept is an ordered list, but scott.emps, that is the employees table in the Scott database, which is, I'm accessing via JDBC, right? So I'm combining a ordered collection with an unordered collection, so the result is unordered, right? Then lastly, here I've got I'm reading from the same result, the same collections, so I've got dept in a ordered list. E is from an unordered table, but in the middle of the query, I've got order by salary descending. So from that point on, now I'm working on an ordered collection, and so I take the top 3 employees. I print out their department number and email and name, and so the result of this query is a list. So I've extended the relational algebra, which is unordered collections, into unordered or ordered, depending on what kind of computation you're doing. So modifying data is, DML, also known as data engineering. It seems to be a a useful application of this stuff. So here's a SQL script that does several DML operations. So we start off with an employees table. We're going to look at it in SQL, then we're going to look at how the same thing translates into Morel, and just, well, have a look how it looks different, and is it a better representation of the problem? So we delete all employees who have a salary greater than 1,000. Then we add one employee. Then we update the table, and then we double the salary of all managers, right? So a sequence of operations, and then finally we commit the result. So there's clearly an order dependency in this, right? We can't change the order of these statements. My first attempt to add this was, well, let's just add insert, update, and delete statements to Morel. So this was my attempt at what it would look like. But then I realized this isn't a functional program anymore, because delete E in scott.emps, I'm modifying the scott.emps table, right? And that's kind of something you don't do in a functional program. And then, of course, because scott.emps has been modified, this second step I'm working on, it can't be reordered, because I have to work on the employees table after the first statement has taken place. So I thought, well, what would a functional programming language do? Well, a functional programming language wouldn't actually modify the table, it would create a new table, right? So we're saying, run this query and find all employees whose salary isn't greater than 1,000, and that becomes emps2, the new employees table. You can think of these as snapshots, right? So, and then the next statement is we take the employees table 2, which is what came out of the first statement, and union it with this one record, right? So that's now our insert statement. And then to do the update statement, we start with emps3, the third snapshot, right? And we say, okay, well, if they're a manager, we output the record with double the salary, otherwise we output the original record. So that's what update looks like in this. So now it's absolutely explicit which version of the table I'm working on. And finally commit. So what I'm doing is saying, this is the only mutation in the entire program, right? All of the other is pure functional programming language, nothing's been modified. Finally, I'm just writing to the outside world, and this is the only kind of magical command, right? So what's good about this? Well, this allows me to do incremental computation. Because if I'm interested in saying, let's find all the records I added between, emps4 and the original emps. In other words, during this script, and then maybe add them to some summary table, right? I can easily compute these things, right? I'm not literally materializing these things in memory. In fact, this is just going to be a piece of algebra. Perhaps if this is backed by like an iceberg table, it will identify the partitions that have been added during this script. It's potentially very efficient. And then I can write something. I'm doing incremental view maintenance here, updating the summary table. This is just not possible using SQL. Your DBMS is doing this under the covers, but it's accessing snapshots that you don't have access to via SQL. But if you do it using Morel, then you do have access to these intermediate results, and you can work on these deltas and whatever. So it makes it possible to. The functional model is actually closer to the way your DBMS works, and I think it's just a more natural way of just getting your hands on the data. So I'm going to skip over a little bit of stuff.
You've got like 5 minutes.
Okay, I'll just cover a couple of extra slides. In fact, I'm just going to skip over all these. So, all right, this is cool. This is cool. So, I call this mathematical optimization, which is you don't think this wouldn't seem like a query problem at all, but let's suppose you've got a bunch of cake ingredients, right? You've got recipes to make chocolate cake and recipes to make banana cake. Each banana cake sells for $4, each chocolate cake sells for $4.50, right? I've got a certain amount of ingredients. How many cakes should I make to maximize profit, right? This doesn't seem like a query problem at all, but it can be expressed in Morel because I'm encoding the amount of, so B is the number of banana cakes I make and C is the number of chocolate cakes I make, and it's going to iterate over all the possible numbers and, as it were, a query over all integers or all pairs of integers and return the value where profit is maximized. And as it happens, it's maximized when B is 29 and C is 14. In other words, I need to make 29 banana cakes and 14 chocolate cakes. So this is an example of the kind of problems that Morel can solve that a regular SQL relational query language can't solve. So I'm going to have to stop here, but conclusion is of all these various things, paradigms in the galaxy of ways I can process data, then Morel has just expanded the reach of SQL. Please give it a try. I'm available for questions afterwards in office hours, and thank you.